Hey, hi and welcome back. So in previous video, we discussed about motor driver IC, which is L293D. So now we have the background knowledge of L293D and now it's time to discuss how we need to connect it with the microcontroller. Alright, so without wasting any time, now let's start with this video, which is about understanding circuit of motor driver IC. So now let me tell you what you're going to learn in this video. So the first point is circuit explanation of L293D section. So we will discuss the circuitry of L293D section in detail. I hope that till now you have a good clarity about how the circuitry of the L293D will be. So we will discuss the circuitry in detail in this video. And then the next point is interfacing of L293D section with the microcontroller. Okay. So we will see how we need to connect the L293D with the microcontroller. Alright. So that's how basically we are going to cover this video and you will definitely enjoy this video. Alright. So now let's start with this video. So this is basically the circuitry of L293D section and the circuit is actually very simple. So you can see I have connected VCC12 plus 5 volt. Then these 4 pins are actually connected to the ground, pin number 4, 5, 12 and 13. And after that the pin number 8 is actually directly connected to the power supply that we are using to power our system. Okay, and we are using 12 volt. That's the reason this particular pin is actually connected to the plus 12 volt. Okay, and these are actually pin number 3 and pin number 6. To these pins we are actually going to connect the motor. So this is actually the symbol for the connector. We are going to use one connector. When I will show you the practical demonstration at that time, you will know how exactly the connector look like. So we are going to insert the wires of the motor in that particular connector. Okay. And later we can drive the motor. Okay. By providing the appropriate logic on this pin number 2 and this pin number 7. Alright. So when you provide, when you provide logic 0 here and when you provide logic 1 here, because of that this motor will start rotating in clockwise direction. And if you alter the logic, if you provide logic 1 here and if you provide logic 0 here, then the motor will actually start rotating in anti-clockwise direction. So that's how basically we change the polarity of the motor. Okay, and in the same way, on this side also we are going to use connector, and to this particular connector the motor will be connected like this. And then by providing the appropriate logic on pin number 15 and pin number 10, you can actually rotate this particular motor in clockwise direction or you can rotate it in anti-clockwise direction. Okay, so you have to provide appropriate logic on these 2 pins 15 and 10 in order to rotate the motor in the appropriate direction. So I hope that that's clear. So this pin number 2, pin number 7 and then pin number 10 and pin number 15 will be connected to the GPIO pin of the microcontroller. Okay, so you can connect these 4 pins of this IC to any of the GPIO pin out of 23 which you like. Okay, but I have connected this particular pin number 1 and pin number 2 to a special pin. Okay, so we discussed that GPIO stands for general purpose input output. So you can use the GPIO pin of microcontroller for output in order to generate logic 1 or logic 0, or you can also use it to read logic 1 or logic 0. And then we can also use the GPIO pin for the general purpose. And we discussed that every GPIO pin in ATmega 328 microcontroller is going to have a special function. In the same way, I am actually going to use a special function in order to drive these pins of this IC. And that function is actually called as PWM. PWM stands for pulse width modulation, and PWM is actually a technique which is used to drive, to control the speed of motor. So by providing the appropriate signal to these pins, we can actually control the speed of motor. So I'm not discussing this PWM topic here because this particular topic is little big. So at this point in time, I just want to tell you that I'm actually using this particular feature, which is actually PWM, which stands for pulse width modulation. And I'm going to use any pin which supports PWM feature. And when we discussed the pin configuration of Atmega 328 microcontroller, at that time I told you that there are different pins which supports the PWM feature. Okay, and you can actually use any of those pins to drive these pins of this IC. But it's not like you should use only PWM pins of the microcontroller. Even if you use a general purpose pin which do not support PWM feature, still you can actually use that particular pin. In that case, you won't be able to control the speed of the motor. That's the only point. But if you are using a pin which supports PWM feature, then you will be able to control the speed of the motor. Okay, so that's all about the circuitry of L293D. And after that, if you see here, I have connected two capacitors of 10 microfarad and 0.1 microfarad. So the reason for connecting these two capacitors, we have already discussed when we discussed this 7-segment display. If you have placed this IC at a little longer distance from the power supply, then this capacitor 10 microfarad is actually going to help to fulfill the sudden current requirement of this particular IC. Okay, so that's basically the first application of using a 10 microfarad capacitor. And I told you that we are connecting this capacitor in parallel to this one. The reason is it's going to reduce the equivalent ESR, which stands for ESR stands for equivalent series resistance. So when we connect two capacitors in parallel, it's going to reduce the ESR. As a result, this capacitor will be able to deliver the power quickly to this particular IC. Okay, but even if you don't connect these two capacitors, it's completely fine. Okay, in our design. And one more thing that I want to tell you, which I missed in SSD section, if your power supply is little noisy, then based on the noise or based on the ripples which are there on your power supply, you have to select the appropriate value of capacitor. And we discussed the impedance versus frequency plot for the capacitor, and we saw that based on the frequency, the capacitor is actually going to provide different impedance, right? So based on the ripples frequency, you have to select the appropriate value of capacitor here, and that capacitor value actually it will change from circuitry to circuitry, okay, or hardware to hardware. The reason is it actually depends on the power supply that you are using, and also depends on the noise which is produced or the ripples which are there on the output side of that particular power supply. If your power supply is pure, there is no noise, very less noise on the output side of power supply, then you don't have to connect the capacitor, okay, in order to filter out that noise. But if your power supply is producing a noisy plus 5 volt signal, then you have to check on the DSO what's basically the frequency of that particular ripples which are generated by your power supply, and accordingly you have to select a suitable value of capacitor. And I hope that you know how to select the value of capacitor based on the frequency. Okay, so same principle you have to use here. If your power supply is producing the ripples with certain frequency, then you can choose a suitable value of capacitor in order to suppress those ripples. Okay, so that's all about the motor driver section and its circuitry. I hope it's clear. Now, the interfacing between the motor driver section and the controller is pretty simple. As I told you, you can actually use any GPIO pins in order to drive the different pins of L293D. So you can see here, I'm actually using these pins PD5, 6, 7, then PB0, 1 and 2 in order to control these pins, okay, input pins of the driver. And if you see here, PB1 and PB2 actually supports the PWM feature. That's the reason I have connected PB1 and PB2 to the motor 1 enable and motor 2 enable pin. Okay, so they're actually going to produce this kind of signal, square wave signal like this. And there is actually one parameter which is called as duty cycle, duty CYCLE, and duty cycle actually decides for how long this waveform will be, there will be logic high, and for how long there will be logic low. So if the duty cycle of the this waveform is 100%, then what will happen, the signal will be like this. Okay, all the time it's going to be high. But if the duty cycle is 50%, then what will happen, the signal will be high for half the time and it will be low for half the time. Now here in this case, we were actually providing, let's say that 10 watt of power. Okay, but in this case we are just providing 5 watt of power. As a result, with this, you can control the speed of motor, because here we are actually changing the power that we are providing to the motor. So that's basically the simple principle of PWM, which stands for pulse width modulation. So you can see we are actually modulating the pulse by changing the duty cycle. Okay, so this is very simple. You can read more about PWM feature. Okay, you will really enjoy learning the PWM feature. Okay, so that's the reason I have connected PB1 and PB2 to motor 1 enable and this motor 2 enable pin. Okay, and with this we will be able to control the speed of both the motors. So when I will show you the practical demonstration, at that time it will be much more clear to you. Okay, and I'm sure you will definitely enjoy that practical demonstration. Alright, so that's what I wanted to tell in this video. I hope that every single thing that we discussed in this video is now clear to you. And if you still have any kind of doubt, then definitely you can reach to me and I will help you with that. Alright, so now I will see you in the next video, which is about schematic design of motor driver. So I will see you in the next video now.